Hi, welcome to my YouTube channel. Today we will discuss about insulation resistance testing. Insulation resistance basics. Insulation testing is a bit like pressure checking. You can look for leaks in a plumbing system by forcing water through at a high pressure. The increased pressure makes the leak easier to spot. The electrical version of pressure is voltage. In insulation testing, we use a relatively high DC voltage to make leakage current more apparent. When leakage is more apparent, insulation tester exhibits low resistance, which means insulation has been deteriorated. Now, let's discuss how did Megger become synonym for insulation tester. Megger was founded in 1889, making it 135 years old. The company was established by Sidney Evershed and Ernest Vignolles, who invented the first insulation tester. Later, in 1903, Megger was registered as a trademark. The original insulation tester, invented by Evershed, was called a Megger, a name derived from megometer. Over time, the brand name became so well known that it started being used generically to refer to any insulation resistance tester. Insulation tester has 3 leads. Red representing positive terminal denoted by L or positive sign. Blue representing guard terminal denoted by G or ground sign. And black representing negative terminal denoted by E or negative sign. Knobs for voltage selection and function selection. And we have to press and hold or lock start or test button to conduct the test. Figure shows typical connection for insulation test of cable system. In the diagram, the positive terminal of the Megger is connected to the phase of a conductor under test, while the negative terminal is connected to the another phase of a conductor's and the sheath or armor of the cable. This setup allows you to measure the insulation resistance between different phases of the power cable and between the conductors and the sheath or armor. In the diagram, the positive terminal of the insulation tester is connected to the high voltage side of the transformer, while the negative terminal is connected to the ground. This setup measures the insulation resistance between the high voltage side and the ground. Table shows the various configuration for conducting insulation resistance test on the power transformer. First configuration is between HV and LV. Second configuration is between HV plus LV and earth, and third configuration is between LV plus HV and earth. In power transformer, insulation resistance test is also conducted between core, frame, and tank known as CFT insulation test, where test voltage is usually of 2.5 kV or less. Now we shall discuss effect of temperature on insulation resistance. The resistance of insulating material decreases with an increase in temperature. If we want to make reliable comparisons between readings, we should correct the readings to a base temperature, such as 20 degrees Celsius. Tests by the time resistance methods are relatively independent of temperature effects, giving relative values. We shall discuss time resistance methods too. The table provides temperature correction factors to adjust insulation resistance values to a base temperature of 20 degrees Celsius. For example, if an oil-filled transformer has an insulation resistance of 6 gigaohms at 35 degrees Celsius, you can use a correction factor of 2.80 to convert it to the equivalent resistance at 20 degrees Celsius. This results is 16.8 gigaohms. Minimum value for insulation resistance is usually followed as per manufacturer guidelines. In case where such guidelines are not available, then we shall follow minimum criteria to determine the minimum value for insulation resistance. Shown formula is used to determine minimum values of insulation resistance for AC or DC rotating machines. Similarly, shown formula is used to determine minimum values of insulation resistance for power cables. Again, similarly shown formula is used to determine minimum values of insulation resistance for power transformers. Now we shall discuss about the time resistance method. It is a reliable way to assess insulation quality, relatively unaffected by temperature variations. It leverages the absorption characteristics of good insulation versus moist or contaminated insulation. By taking successive readings at specific intervals, you can calculate the dielectric absorption ratio, DAR, and the polarization index, PI. DAR, the ratio of a 60-second reading to a 30-second reading. PI, the ratio of a 10-minute reading to a 1-minute reading. These ratios help identify the condition of the insulation, with higher values indicating better insulation quality. This method is often referred to as an absorption test. The graph highlights the importance of the time resistance method for assessing insulation resistance. Curve A shows that good insulation exhibits a continual increase in resistance over 5 to 10 minutes. In contrast, Curve B indicates that contaminated insulation starts with higher resistance but plateaus quickly. This demonstrates that relying solely on initial spot test results could be misleading, as they might not reveal underlying issues with the insulation. In final, let's discuss about thumb rules. Temperature correction. For every 10 degrees Celsius increase in temperature, have the resistance. For every 10 degrees Celsius decrease in temperature, double the resistance. Insulation resistance based on voltage. Insulation resistance should be approximately 1 megohm per kV of operating voltage. As per CBIP specifications, the acceptable value is 2 megohms per kV. Thank you for watching. Source credits to Megger and Fluke. Please like, share, and subscribe.